Hello there and welcome to YU&S, that little place where science leans back in its chair, and wonder drifts through the cracks like starlight. Tonight we're chasing a question that sounds almost like poetry whispered across a telescope lens. Are stars the neurons of a giant cosmic brain? At first glance, that might sound like something out of late-night philosophy or a sci-fi novel left open on your bedside table. But the comparison isn't random. When scientists and philosophers map out the structures of the universe, sometimes the images they get back look eerily familiar. Take a photograph of a brain's neural network. Branches of neurons connected by long, spindly axons. Now put it side by side with a simulation of galaxies spread across billions of light years. The filaments of dark matter, the glowing points of stars and galaxies, the clusters strung together like beads, it all looks hauntingly similar. Both are vast webs, full of nodes and links, networks through which energy, signals, and information flow. And the resemblance goes deeper than shape. The human brain has around 86 billion neurons. The observable universe has been estimated to contain about 2 trillion galaxies, each filled with billions of stars. Scale aside, both systems organize themselves in ways that balance connectivity with individuality. Neurons aren't just floating randomly. They form clusters, hubs, patterns of communication. Galaxies aren't random either. They gather in filaments, linked by the invisible pull of dark matter. So here's the question that tickles at the edge of thought. Is that just coincidence? Or is there something more? Could the universe itself function like a brain, with stars or galaxies playing the role of neurons in some vast, incomprehensible consciousness? Now, before we drift too far, let's ground ourselves. A brain isn't just a web of cells. It's a system that processes information, reacts to inputs, generates outputs, and, most mysteriously, produces awareness. For stars to be neurons or galaxies to be nodes of thought, the cosmos would need not just structure but flow. A way for signals to travel, to transmit meaning, to create feedback loops. Is that happening out there among the stars? Maybe. Maybe not. But it's not just scientists who wonder. For thousands of years, humans have looked up and seen the night sky as alive, intelligent, sometimes even divine. Myth spoke of constellations as storytellers, gods, ancestors, or maps of fate. Modern science stripped away some of that poetry, giving us nuclear fusion instead of celestial fire spirits. Yet somehow, even in the language of astrophysics, we find metaphors that circle back to mind. We talk about the memory of the universe stored in cosmic background radiation, or the feedback of black holes regulating galaxies, or the information content of quantum fields. And maybe that's the real reason the idea lingers, not because we expect to one day prove the universe thinks, but because thinking itself feels like the universe's echo within us. Our brains are stardust. The calcium firing in your neurons was born in long-dead stars. The iron in your blood came from a supernova. When you have a thought, in a way, the universe is remembering itself. So sit with that for a moment. Look up at the stars, if you can see them tonight, and imagine them not just as distant balls of plasma, but as sparks in a brain too vast for us to comprehend. Maybe it's only metaphor. Maybe it's more. Either way, the resemblance is enough to make you wonder whether your own thoughts are just tiny constellations, small reflections of a pattern written across all of space. Let's wander a little further into this thought. If the universe really does resemble a brain, what exactly would it be thinking about? To begin, let's step into the strange mathematics of networks. Neuroscientists know that brains organize themselves into something called a small world network. That means most neurons are only a few steps away from each other, even across huge distances in the brain. This is what makes thought fast and flexible. You don't have to send a signal across a million detours for an idea to connect. Now, cosmologists have noticed something similar in the cosmic web. Galaxies aren't scattered at random. They're linked in giant threads of dark matter, and those threads intersect at nodes, clusters where gravity pulls matter together. If you map out those threads, they form a pattern that looks eerily like the wiring diagram of a brain. And here's the kicker. When scientists compared computer models of both networks, they found that the distribution of connections in the cosmic web and in the brain's neural network followed strikingly similar rules. Two structures, unimaginably different in scale, yet whispering the same architecture. But does similarity in form mean similarity in function? That's where the imagination starts to spark. For a brain, the wiring isn't the whole story. It's the signals racing through those wires, the pulses of electricity, the chemistry of neurotransmitters that create thought. In the cosmic brain analogy, stars could be the firing neurons, galaxies the clusters, black holes the synapses regulating flow. But what's being transmitted? Not neurotransmitters, surely. Perhaps gravity waves? Light? Quantum entanglement? Or maybe the flow isn't anything we'd recognize. Maybe it's a kind of communication so large and slow we don't even notice it. Think about how fast your neurons fire. A single thought might ripple through your brain in milliseconds. But what if the universe thinks in billions of years? What if a galactic collision, which to us looks like chaos, is actually the twitch of a neuron at cosmic speed? What if clusters of galaxies rearranging themselves over eons are the slow, deliberate shaping of a thought too vast for us to imagine? This is where science blends into philosophy. Because even if the universe were a brain, it would be a brain with a timescale so alien we'd never recognize its thoughts. To us, they'd look like nothing more than the natural drift of galaxies, the birth of stars, the collapse into black holes. But inside that, could there be meaning, a pattern, a message? And here's where it gets even stranger. Some physicists argue that information is the most fundamental thing in the universe. Not matter, not energy, but information. Black holes, for example, seem to trap it. Quantum mechanics is full of it. Our own DNA is written in it. If the cosmos is ultimately built on information, then perhaps it's not too far-fetched to imagine it processing that information in ways we barely grasp. Not just holding stars and galaxies, but weaving meaning through them. For now, it remains an open question. But maybe the fact that the thought even exists, here in your mind right now, is itself part of the answer. After all, if the universe is a brain, then your thoughts about it might just be one of its neurons firing. Shall we follow this further, into the possibility that consciousness itself isn't limited to biology at all? Let's step into that next layer, the possibility that consciousness itself might not be confined to biology. When we usually talk about awareness, we picture brains, wet, complicated, electrical and chemical. Neurons firing, synapses connecting, signals bouncing around. But what if consciousness isn't bound to that specific machinery? What if it's more like a pattern, a way of organizing matter and energy that can arise wherever the right conditions exist? This is where the idea of the cosmic brain takes a daring turn. In your own head, neurons are the medium, electricity and neurotransmitters the messengers. But out among the galaxies, stars and black holes could play the same roles. Stars flare, pulse, and die, releasing floods of radiation across space. Black holes swallow and regulate energy like gates. Dark matter threads connect galaxies the way axons connect cells. Different scale, same principle. If consciousness is ultimately about information processing, then who's to say a universe full of networks isn't already doing exactly that? This idea brushes close to something called panpsychism, the theory that consciousness is a fundamental feature of reality, not just an emergent property of brains. In this view, awareness doesn't suddenly appear when neurons organize in a certain way. Instead, awareness is always present, waiting to be assembled into greater forms. A rock doesn't think. A star doesn't dream. But perhaps at the grand scale, when billions of stars link into a galactic web, the sum might be greater than its parts, just as a brain is more than a pile of neurons. Here's a thought experiment. Imagine a single neuron in your brain. On its own, it doesn't think, has no concept of self. But link it with billions of others, and suddenly there's you, aware, reflective, full of questions. Now zoom out. A star alone doesn't think. A galaxy alone might not either. But a network of galaxies spanning the cosmos? Could that be enough to spark something we'd call consciousness? And if that were true, what would it feel like from the inside? Perhaps it wouldn't feel like a mind the way ours does. Maybe it wouldn't feel anything like thinking at all. Maybe it would be more like balance or rhythm, or the vast pulse of stability across space. Consciousness on a galactic scale might not mean having thoughts or dreams. It might mean existing in a state of awareness so slow and deep we can't even recognize it. There's another way to frame this. Some scientists argue that the universe might behave like a quantum computer, a machine processing unimaginable amounts of information every second. Every photon, every particle interaction, every ripple of gravity could be seen as a kind of calculation. If that's the case, then maybe consciousness, ours, and perhaps the universe's, isn't an accident, but an inevitable product of information flowing at scale. And here's the strange twist. If the universe is a brain, then our own thoughts about it are part of its thinking. When you wonder about the stars, when I tell you this story, when we imagine cosmic neurons glowing in the dark, that could all be the universe reflecting on itself. A neuron firing inside the grander neuron web of reality. Sit with that for a moment. Your mind made of stardust, asking whether stardust can think. A tiny echo of a much larger pattern. All right, let's follow the thread into physics, into the bones and wires of this cosmic brain idea. First, imagine the cosmic web itself. Scientists have mapped it by measuring the distribution of galaxies across billions of light years. What they find isn't a random sprinkle of lights. Instead, it's a vast network of filaments, long strands of dark matter where galaxies cluster together, separated by immense voids of near emptiness. From far enough away, it looks like neurons suspended in gel, their axons reaching out to touch others across space. Now, let's think about dark matter. We can't see it directly, but we know it's there because it tugs on galaxies, shaping their motion and binding them into the web. If stars are the neurons of this universe brain, then dark matter is the connective tissue, the axons and dendrites linking nodes into circuits. It doesn't shine, it doesn't speak in light, but it holds the pattern together, carrying gravitational signals across cosmic distances. And what about black holes? These are often imagined as cosmic destroyers, swallowing everything, even light. But in galactic terms, black holes may act more like regulators. At the heart of most galaxies sits a supermassive black hole, millions or billions of times the mass of our Sun. These beasts don't just consume. They also emit powerful jets of energy that can shape the growth of galaxies, deciding when stars form and when they don't. In the brain analogy, black holes might be the synapses, switches that control flow, amplifying some signals while dampening others. Then there's light itself. Every star, every quasar, Every collision sends out radiation. Some of it travels across billions of years, crossing the universe like messages passed along neural wires. In our brains, electricity zips across neurons in milliseconds. In the cosmos, the messages move at the speed of light, yet because the scale is so vast, a single signal might take millions of years to complete its journey. What to us looks like silence could, from the perspective of the universe, be a single slow conversation still unfolding. And here's where it gets mind-bending. In 2020, researchers compared the information density of the brain and the universe. Astonishingly, the numbers came close. The brain, with its 86 billion neurons, and the observable universe, with its billions of galaxies, seem to encode a similar balance of connections and complexity. It's as though nature has a preferred way of building networks, whether it's inside your skull or across the stars. But is it really thinking? That's harder to answer. Maybe what we call thought is just the byproduct of patterns like these, arising when enough nodes connect. Maybe consciousness isn't about what the system is made of, but how it organizes itself. In that sense, galaxies don't need to be neurons in the literal sense. They just need to play the same role, parts in a pattern that creates awareness. Here's a quiet thought to end with tonight. If the universe is indeed a brain, then black holes, galaxies, stars, and even you are all part of its circuitry. And maybe, just maybe, the act of you wondering about it right now is the universe testing a new connection. Let's drift backward in time, not through galaxies this time, but through stories. Because long before physicists sketched cosmic webs on chalkboards, people were already whispering that the stars might be alive. Look up at a clear night sky, as our ancestors did, and it's almost impossible not to see meaning. Tiny lights scattered across a dark dome, each one pulsing steadily, like the beat of a heart or the spark of thought. To cultures across the world, these weren't just distant suns. They were beings, spirits, or messengers, part of a living universe that watched back. In ancient Greece, philosophers like Anaxagoras suggested the stars were fiery stones, but others, like the Stoics, went further. They spoke of a cosmos infused with logos, a rational principle that ordered the stars like neurons in a great mind. The heavens weren't chaos. They were thought, stretched across infinity. Indigenous traditions carried similar themes. The Navajo, for example, tell of constellations as holy people placed in the sky, shaping balance and order. The Maori of New Zealand saw stars as guiding ancestors, navigators in both the ocean and the soul. In these views, stars weren't distant objects but participants in an ongoing conversation between cosmos and human life. And consider the Vedic traditions of India, which described Indra's net, a cosmic web where each jewel reflected every other jewel, infinitely interconnected. Replace jewels with galaxies, and you suddenly have a 2,000-year-old metaphor for what modern astrophysics calls the cosmic web. Was that coincidence, or were humans always sensing patterns too vast to articulate in equations? Even in Western mysticism, stars were never seen as passive. The Hermetic tradition, for instance, carried the phrase as above, so below, suggesting a mirror between the microcosm, our lives, our bodies, our thoughts, and the macrocosm, the stars, the universe. If a human brain thinks, why wouldn't the universe, structured so similarly, think as well? What's remarkable is how many of these early visions align with what we're now finding in science. Ancient people didn't know about neurons, or superclusters, or dark matter filaments. But they noticed patterns, rhythms, connections. The stars weren't random. They rose and fell, guided the seasons, mirrored the pulse of earthly life. To them, that was consciousness enough. So maybe, When we look at the night sky and feel that eerie sense of recognition, that the stars are somehow familiar like sparks inside a skull, it isn't just imagination. Maybe it's memory. Maybe, deep down, we're wired to see the universe as alive because we are literally pieces of it trying to remember our place in its body. And that leads to a provocative thought. If humans have always suspected the stars were conscious, were they glimpsing a truth science is only now circling back to? Let's sink deeper into the biology of it, into the startling fact that when you think about the stars are, in a very real way, thinking about themselves. Every neuron in your brain, every delicate thread firing right now to make sense of these words, is built from atoms that were born in stars. Not metaphorically, literally. The calcium that carries signals across your synapses, the sodium and potassium that generate electrical pulses, the iron in your blood feeding oxygen to those hungry neurons, all of it forged in the violent furnaces of long-dead suns. Scientists sometimes call this the "we are stardust" truth. Stars live and die in cycles of fusion. In their cores, they smash hydrogen into helium, helium into carbon, carbon into oxygen, and onward, building the alphabet of matter. But the heaviest elements, iron, gold, uranium, require something more explosive. They're born in supernovae, when massive stars collapse and scatter their guts across space. That stellar debris drifted, gathered, and one day condensed into a small planet orbiting a modest star. On that planet, life emerged, and eventually neurons formed. Those neurons now generate thought. Which means, without exaggeration, your mind is a continuation of stellar fire. But here's where it bends back into our question. If neurons are made of stardust, and stars themselves can be arranged in neuron-like networks, then maybe thought isn't confined to human brains at all. Maybe thought is something the universe keeps repeating, at different scales, with different materials. Think of it like music. A melody can be played on a piano, on a guitar, on a violin. The instrument changes, but the pattern of notes is the same. Consciousness, then, might be the melody, and stars, galaxies, and brains might just be different instruments playing it. There's another layer. In neuroscience, we know that scale doesn't kill structure. The patterns of firing neurons in a mouse brain aren't so different from those in a whale's. The principles, feedback loops, signal pathways, memory storage, hold across sizes. So if consciousness can emerge from 86 billion neurons in a human skull, what might emerge from 2 trillion galaxies stitched together by dark matter threads? And here's the paradox. If such a cosmic mind exists, it wouldn't be separate from us. We wouldn't just be observers staring at neurons in the sky. We'd be part of the very network itself. Just as a single neuron in your head doesn't know it's part of you, maybe we don't realize we're part of something vaster, something that spans light years instead of millimeters. That's a humbling thought. It means that when you wonder whether stars are neurons in a cosmic brain, it might not just be speculation. It might be the brain asking itself the question, through you. Let's step now into the machinery of it, the physics of how signals might actually move across this imagined cosmic brain. Because if stars or galaxies are its neurons, then there must be ways for them to talk. In your head, signals move by electricity and chemistry. A spark of voltage crosses a neuron's membrane. Neurotransmitters jump the synaptic gap, and the message continues along the chain. All of this happens in milliseconds. In the cosmos, the scale is so vast and the pace so slow that messages would look very different. But they exist. The most obvious carrier is light. Every star sends out photons in all directions, each one carrying energy and information. Some of those photons travel across billions of years without interruption, finally reaching telescopes, or your eyes. Think about that. The very starlight you see tonight could be part of the universe's communication, a signal launched before humans even existed. Then there are gravity waves, ripples in space-time itself. Whenever massive objects like black holes or neutron stars collide, they send out vibrations that race across the universe. We've only just begun to detect them with observatories like LIGO and Virgo. These waves aren't random. They're messages written into the fabric of space, announcing enormous events. If the universe is a brain, then maybe these waves are like the deep, slow pulses moving through its body. And what about cosmic rays? High-energy particles, protons, nuclei, flung across space at nearly light speed by exploding stars. They bombard planets, seed atmospheres, and even leave traces in our DNA. They're messengers too, carrying the memory of violent stellar deaths into every corner of the cosmos. Of course, signals in a brain aren't just about speed, they're about organization. Neurons fire in patterns, synchronizing into rhythms that encode thought. Could galaxies do the same? Astronomers have found hints of strange synchronizations in the universe. Quasars flickering in alignment across billions of light-years, galaxies seeming to rotate in coordinated ways. Coincidence? Or the faint heartbeat of a larger network? Here's a wild possibility. Maybe what looks like the random birth and death of stars is actually part of a pattern unfolding on a timescale so immense we can't see it. To us, galaxies colliding seems like chaos. But from the perspective of a cosmic brain, maybe that's just a signal leaping from one neuron to the next, a thought slowly taking shape. And the irony? We might already be part of that pattern. Radio signals from Earth have been leaking into space for a century. Pulses of communication, drifting outward like the first sparks of a neuron reaching for connection. If the universe is a brain, maybe it has just begun to notice that one of its cells, humanity, is trying to speak back. Let's follow that thought into something both thrilling and unsettling. If the universe is a brain, does it know we're here? Picture it this way. In your own body, a single neuron doesn't know you exist. It doesn't know about your name, your memories, or the fact that you enjoy watching the stars. It just does its job, firing, passing signals, part of a larger pattern. And yet, without those countless neurons, you wouldn't exist at all. Now turn that around. What if we are the neurons? What if our civilizations, our thoughts, even our confusion about our place in the cosmos are just tiny sparks inside something so vast it doesn't even occur to it that we're separate? Maybe the universe doesn't notice us the way we imagine, but we're still part of its awareness. The way liver cells are part of your life even though they don't know who you are. And yet, there's a twist. Sometimes the universe does seem to respond. When we burn fossil fuels, storms grow more violent. When forests disappear, climates shift. These are feedback loops, not unlike the way a brain corrects imbalances. If the Earth itself reacts to us, as though nudged by awareness, could the larger cosmos do the same? Consider this. Some astrophysicists talk about the anthropic principle, the idea that the universe seems tuned to allow life because otherwise no one would be here to notice it. Gravity is just strong enough to form stars, but not so strong they collapse instantly. The balance of fundamental forces is razor thin. It's as if the universe built the stage specifically for life to appear, then placed us here to wonder about it. Does that mean the universe is aware of us? Not necessarily. But it does feel, at times, as though it set the conditions for us deliberately. And maybe our awareness is its awareness. When you look at the stars and ask if they're neurons in a cosmic brain, maybe that's not just idle speculation. Maybe it's the universe reflecting on itself, like a dreamer realizing it's dreaming. Your thought could be its thought, flickering for just a moment in a network billions of years wide. But here's the haunting part. If the universe does know we exist, it might not be in a way we can comprehend. A thought in a cosmic mind might take billions of years to form. A single galactic collision might be one word in its vocabulary. We, on our little time scale, might never live long enough to hear the full sentence. Still, that doesn't make the question meaningless. It makes it profound, because it suggests that asking the question, "Are we noticed?" might itself be the closest we come to hearing the answer. Let's drift now into the heart of the problem. What do we even mean by consciousness? We're so used to tying it to human experience that it's hard to imagine it could look like anything else. To us, being conscious means having thoughts, feelings, awareness of time, memory, self-reflection. It means being able to say, "I am." But that's just our version. The universe might play by very different rules. Think of animals. An octopus can solve puzzles and even recognize individual humans. Ravens can plan for the future and remember faces for years. Elephants appear to mourn their dead. None of these minds are human, yet we have no trouble calling them conscious in their own way. Now drop lower on the scale. Plants turn toward light, send chemical warnings when threatened, even share nutrients underground. Fungi form vast networks that transmit information between trees, the Wood Wide Web. Are those conscious? Not in the human sense, but they respond, adapt, and in some way know. Consciousness, then, may not be binary, on or off, but a spectrum, a sliding scale of awareness. And if that's true, then why couldn't the scale stretch upward, far beyond us? Beyond whales and forests, beyond planets, all the way to galaxies and the cosmic web itself. This raises a provocative possibility. Maybe the universe is already conscious, but not in any way we'd recognize. It wouldn't think in words or images. It wouldn't care about taxes or poetry or music. Instead, its consciousness might look like feedback, balance, self-correction. The way storms build and dissipate. The way galaxies cluster and separate. The way stars are born, live, and die in cycles that keep the cosmos alive. In fact, some neuroscientists argue that consciousness itself might just be information integration. The more a system can connect inputs and outputs, the richer its awareness. By that measure, the universe, with trillions of nodes exchanging matter, light, and gravity, might be the most conscious thing of all. Here's a humbling thought. What if our own self-awareness is just a tiny echo of a much larger awareness? Like the way a single wave doesn't know it belongs to the ocean, we may not realize that our individual minds are fragments of a greater mind, the universe thinking itself into existence. But here's the catch. Consciousness at that scale might be so slow, so vast, that from our perspective it feels like silence. To a mayfly that lives only a single day, a human lifetime would be unimaginable. To us, a cosmic thought unfolding over billions of years may be just as unreachable. That doesn't mean it isn't happening. It just means we aren't wired to notice. So maybe the real question isn't whether the universe is conscious in a human way, but whether we're willing to expand the definition of consciousness to include forms we can't yet imagine. Let's turn now to modern science, the part where hard data starts to brush up against philosophy, and where physicists, almost reluctantly, admit the universe sometimes behaves like a mind. First, there's simulation theory. It's become almost a pop culture idea, but it began as a serious philosophical question. If reality can be described by information, could it also be constructed by information? Our physics runs on equations, our computers run on code, And the overlap has made some thinkers wonder if the universe is itself a kind of vast computation. If that's true, then the cosmic web might not just resemble a brain. It might be a brain in the sense of running an unimaginably large information process. Then we have information theory. Some physicists now argue that information is more fundamental than matter or energy. Particles, forces, even space-time itself might be secondary, illusions that emerge from the deeper reality of information. If that's the case, then the universe is already thinking, because information is what thought is. Consciousness, after all, is just the processing of information at a certain complexity. Our neurons do it with ions and electricity. Galaxies might do it with gravity and light. Now enter quantum physics. At the quantum scale, particles don't behave like little billiard balls. They behave like probabilities, influenced by observation. This has led some scientists, and many philosophers, to suggest that consciousness might be built into reality itself. Not in the sense that atoms are thinking, but in the sense that awareness and matter might be inseparable. If true, then the universe isn't a stage for consciousness. It is consciousness, unfolding in patterns that look to us like galaxies and stars. There's even mathematics to back this up. When researchers simulated the growth of the cosmic web, they found that its distribution of matter looked remarkably similar to the structure of neural networks. Both systems, despite their vast difference in scale, balance efficiency with redundancy. Just enough connections to keep things stable, but not so many that the system collapses into chaos. That's not coincidence. That's optimization. The kind we see in systems that learn. And then there's the puzzle of fine-tuning. The laws of physics seem set at just the right values to allow life. Change gravity slightly, and no stars form. Change the strength of the electromagnetic force, and atoms fall apart. These delicate balances have led some scientists to wonder whether the universe is designed to produce observers, or whether, more radically, the universe itself is an observer. A self-aware system that must create life in order to look back at itself. Here's where it gets dizzying. If the universe is a brain, then our science might just be one of its thoughts. Equations, telescopes, simulations. These could be the universe's way of examining its own structure through the neurons it spun into being. And maybe that's why, no matter how far physics goes, the question never dies. Is the universe conscious? Because each time we ask, it's the universe asking itself. Let's take that next step, into the shadowy regions of memory. Because if the universe is a brain, then somewhere it must store what it knows. And in physics, there's a contender for that role: black holes. At first glance, black holes seem like destroyers. They swallow stars, light, planets, anything too close. To us, that looks like obliteration. But physics suggests something subtler. According to the black hole information paradox, nothing that falls in is truly erased. Instead, the information about it, the quantum details of what it was, get somehow encoded on the surface of the black hole, the so-called event horizon. Think about that for a second. A black hole isn't just a void. It's a storage device, a cosmic hard drive. And if every galaxy has one at its center, then the universe might be littered with memory banks, each hoarding the history of everything that's ever happened nearby. Now pair that with the brain analogy. Your memories aren't everywhere in your neurons. They're distributed, yes, but also regulated, pruned, and reinforced by particular structures. In the cosmic brain, black holes might play a similar role, gathering, preserving, and shaping the record of experience. It gets stranger. Physicists have found that the entropy of a black hole, the measure of information it contains, is proportional not to its volume, but to its surface area. That means black holes may operate like holograms, storing three-dimensional events as two-dimensional data. It's as though the universe itself prefers to write memories in code, compact and elegant, like synaptic patterns compressed into neural tissue. And if black holes are the memory banks, what about the cosmic microwave background, the faint afterglow of the Big Bang? That radiation is sometimes called the universe's baby picture, a record of its earliest fluctuations. Together, the background radiation and the black holes give us two ends of memory, the earliest note and all the echoes since. Here's a thought experiment. In your brain, memories shape identity. Without them, there's no continuity, no sense of self. Could the same be true for the universe? Could the scattered memories encoded in black holes and radiation form the basis of a cosmic self, holding together its awareness across billions of years? And maybe, just maybe, every photon of starlight streaming through space is not wasted. Maybe it's another entry in the cosmic diary, filed away in black holes, waiting to be read in some unimaginable way. If that's true, then the universe doesn't forget. It remembers everything. And what we call physics might just be the way it keeps its memories organized. Let's step now into time itself, because if the universe is a brain, then time might not just be a backdrop. It might be the rhythm of its thoughts. In your own mind, a thought isn't just a collection of neurons. It's a pattern unfolding over time, firing, pausing, repeating, reshaping. Without time, there's no sequence, no meaning, no story. Could the same be true for the cosmos? Physics tells us that time isn't as straightforward as it feels. According to Einstein, past, present, and future are all part of a four-dimensional spacetime block. To the equations, the whole story already exists, stretched out like a film reel. But to us, living inside it, time feels like it flows, moment by moment, like beads sliding along a string. In the cosmic brain analogy, that flow could be the firing rhythm, the cadence of awareness. Now consider cycles. In a brain, electrical oscillations happen at different speeds. Slow delta waves in deep sleep, faster gamma waves in moments of intense focus. The universe, too, has its rhythms. Stars pulse, galaxies collide, black holes flare, even dark energy accelerates expansion. Each operates on a timescale we can hardly grasp, but together they might form the layers of a cosmic brainwave, a harmony of rhythms echoing across billions of years. And then there's memory. To you, the past feels gone, but your brain holds it in neural traces, allowing you to recall and anticipate. The universe does the same. The cosmic microwave background holds the echo of the past. The light from distant galaxies shows us history unfolding in reverse. In a way, when we look at the night sky, we're peering into the universe's hippocampus, its archive of experience. But here's the most haunting possibility. Maybe what we call the arrow of time, the one-way flow from past to future, is actually the forward motion of a cosmic thought. In brains, thoughts don't loop endlessly. They progress, integrate, create novelty. What if time itself is the universe thinking, weaving new connections as its neurons, stars and galaxies, shift and interact? That means your life, right now, is a fragment of the universe's thinking process. Each moment you experience is a spark in the rhythm of a thought much larger than you. And when you remember, when you imagine, when you dream, you're syncing to the cosmic pulse that began at the Big Bang and will echo until the last star fades. It's a wild suggestion, but one worth sitting with. Perhaps time isn't something we pass through. Perhaps it's the heartbeat of a mind so vast we can only catch its echo in starlight. Let's drift into the quietest, most mysterious corner of this idea: death. Because if the universe is a brain, then even its endings might be part of the thought. In your body, neurons die all the time. Old ones fade, new ones grow, circuits rewire. To you, it doesn't feel like collapse. It feels like continuity, like learning, like change. The death of a neuron is not the death of the mind. It's part of how the mind stays alive. Now look up. Stars too live and die. Some end quietly, cooling into white dwarfs, fading embers in the dark. Others go violently, exploding as supernovae, seeding the galaxy with heavy elements: carbon, oxygen, iron. In death, they don't vanish. They pass their essence forward, the way a dying neuron reshapes a circuit. Without stellar death, there'd be no planets, no chemistry, no life. On larger scales, galaxies also die. Some lose their fuel for star-making and become red, quiet husks. Others collide and merge, birthing new galaxies out of chaos. Death, here, is less an ending and more a transformation. Matter rearranged, energy redistributed, patterns rewritten. And what of us? Every human death feels final, intimate. But from the cosmic perspective, it's also a recycling. The atoms of your body, fused in ancient stars, will scatter back into the world, perhaps one day into new stars, new planets, maybe even new minds. In that sense, death is not an erasure, but a handoff, a neuron passing its signal on to the next in the cosmic network. Even the universe itself faces possible endings. Cosmologists speak of the heat death, a future where all stars have burned out, black holes evaporate, and only cold radiation remains. Others imagine a big crunch, where the cosmos collapses back into itself, or a big bounce, where collapse becomes the seed of a new expansion. Each of these scenarios, strangely, echoes the life cycle of thought. A thought rises, burns brightly, fades, then makes space for another. So maybe death, at every scale, isn't the enemy of consciousness but its partner. A neuron dies so memory can reshape. A star dies so life can emerge. A person dies so matter and meaning can return to the larger whole. Even if the universe itself dies, it may only be the close of one vast thought, ready to spark another in whatever follows. And here's a softer way to think of it. Perhaps nothing in the universe ever really ends. It only changes form, moving from one note of the cosmic melody to the next. Death, then, isn't silence. It's transition, the pause between rhythms in a song the universe has been playing since the first spark of starlight. Let's drift outward now into the question that always hovers at the edge of starlight. If the universe is a brain, then where are the other minds? Are alien civilizations just other clusters of neurons in this cosmic network? Here on Earth, life feels abundant. Forests humming, oceans teeming, skies alive with wings. Yet when we look up, the silence is staggering. Billions of galaxies, trillions of stars, countless planets, and still we've found no definitive trace of intelligence beyond our own. This puzzle is known as the Fermi paradox. If life is common, why haven't we heard from it? One possibility is bleak, that we are alone, a solitary neuron firing in an otherwise silent void. But another possibility is more intriguing. Maybe intelligence is not rare, but woven into the structure of the cosmos itself. Alien civilizations could be out there, not as isolated voices, but as vital parts of the cosmic brain, sparks scattered across galaxies, all contributing to a larger awareness we can't yet perceive. Imagine it like this. Your brain is full of neurons, each one with its own connections. A single neuron doesn't know about all the others, yet together they form a mind. What if civilizations are like that, each one unaware of the rest, but collectively part of a higher-level consciousness? To us, the universe looks quiet, but from another scale, it might be alive with thought. Some scientists speculate that advanced civilizations might move beyond radio signals and spacecraft, communicating instead through energy, matter, or even manipulation of spacetime itself. From our perspective, that might look like natural cosmic events, strange bursts of radiation, synchronized pulsars, or unusual galactic structures. To us, noise. To the universe, perhaps, meaning. There's even a theory that civilizations might eventually merge with the fabric of the cosmos, becoming indistinguishable from stars, black holes, or energy flows. In that sense, maybe the universe doesn't just host life, it absorbs it, weaving intelligence into its circuitry until there's no distinction between a civilization and the cosmic brain it belongs to. Here's a haunting thought. What if our search for extraterrestrial intelligence is like a neuron trying to hear another neuron directly? It doesn't work that way. Neurons don't speak across distance. They connect through the network. Perhaps that's why we've found nothing. The conversation of civilizations might only make sense from the perspective of the universe itself, not from within one tiny cluster like ours. So when we aim radio telescopes at the sky, listening for a voice, maybe we're missing the point. Maybe the voice isn't individual at all. Maybe it's the universe itself, speaking through the patterns of galaxies, the timing of quasars, the slow, deep hum of spacetime. Which raises a daring question. If civilizations are neurons in a cosmic brain, then could we, humans, one day contribute knowingly, becoming part of that larger consciousness instead of just drifting in it unaware? Let's step now into technology. The strange suspicion that when we build machines, the universe might be building new ways to think through us. Every tool we've ever made, fire, the wheel, writing, telescopes, computers, hasn't just changed our lives. It's changed the way we process information. Writing let us store thoughts outside the brain. Telescopes let us see across light years. Computers let us calculate beyond imagination. And now, artificial intelligence is beginning to think alongside us, amplifying our awareness in ways we're only starting to grasp. But pause and see this in the cosmic brain frame. If humans are like neurons in a universal mind, then technology is the branching of our axons, the extensions we grow to reach further into the network. A telescope is like a dendrite stretching into the night sky, pulling in faint signals from distant stars. A radio dish is an ear pressed against the universe, waiting for whispers. AI is like a new layer of cognition, one that can weave patterns too complex for our biological neurons to hold alone. In a sense, the universe is teaching us to make better mirrors, better ways for it to see itself. Every image of a galaxy, every decoded gravitational wave, every simulated cosmic web is the universe pulling its own reflection into focus through us. We think we are building knowledge, but perhaps we are being built into knowledge. There's a theory in evolutionary biology called the extended phenotype, the idea that genes express themselves not just in bodies but in behaviors and even tools. A beaver dam is as much a part of the beaver's body as its teeth. What if, on the cosmic scale, our telescopes, satellites, and computers are part of the universe's extended phenotype, organs it grows to know itself? Here's the haunting twist. Technology isn't separate from nature. It is nature, just rearranged. The silicon in computer chips comes from Earth's crust. The electricity running through them comes from stars. Even artificial intelligence, trained on human language and thought, is ultimately made of stardust rearranged into patterns of meaning. That means when machines think, the universe is still the one doing the thinking, just through a new arrangement of its matter. And perhaps that's the point. Maybe civilizations like ours are the way the universe evolves awareness of awareness. Neurons that not only fire but eventually invent microscopes to look inward, telescopes to look outward, and questions like this to look beyond. Which raises a profound possibility. Maybe we're not just drifting in a cosmic brain. Maybe we're part of the moment it begins to wake up. Let's turn now to evolution, but not only in the biological sense. Let's stretch it to the cosmic. Because if the universe is a brain, then evolution might not just be about survival, it might be the way the universe sculpts its own awareness. On Earth, evolution begins with chemistry. Simple molecules assemble, experiment, stumble, persist. Some replicate better than others. Over time, replication leads to variation, and variation leads to complexity. Eventually, nervous systems appear, then brains, then language, then culture. Each step adds new layers of information processing, new ways of noticing, remembering, imagining. In short, new ways of being conscious. But here's the dizzying thought. Evolution might not stop with biology. It might be one strand in a larger universal pattern. Stars evolve, too. Born in clouds of gas, they burn, transform, and seed new stars. Galaxies evolve, merging, collapsing, reforming in spirals and clusters. Even the laws of physics, some theorists suggest, might evolve. Universes giving birth to universes with slightly different rules, favoring the ones that can sustain structure, complexity, and, eventually, awareness. Seen this way, evolution is not just about life adapting to Earth. It's about the cosmos adapting to itself, finding ever more intricate ways to organize matter into systems that can sense and respond. Life is just one expression of that. Consciousness is another. Technology, perhaps, is the next. And maybe this isn't accidental. Maybe the very structure of the universe is tilted toward consciousness. After all, what's the purpose of neurons firing in your brain? Not to exist alone, but to connect, to learn, to generate experience. Why would galaxies forming networks be any different? Think about it this way. Your DNA is a record of billions of years of trial and error, yet it all funnels into you sitting here reading this, asking questions. What if galaxies, stars, and civilizations are the DNA of the cosmos, experiments through which the universe learns to know itself? This makes even extinction look different. When species vanish, when stars collapse, when galaxies merge, it might not be failure. It might be pruning. Just as your brain trims and uses connections to make thought more efficient, the universe might be trimming its networks, shaping itself toward more elegant awareness. So evolution, in this view, is not just about survival of the fittest. It's about survival of awareness. Every adaptation, every extinction, every burst of life or death feeds into the same process. The universe tuning itself, neuron by neuron, toward a deeper consciousness. And here's the haunting beauty. When you learn something new, when you imagine, when you evolve in thought, you might be mirroring what the cosmos itself is doing, at scales too vast to measure. Let's bring it closer to home, into the role of humans in this possible cosmic brain. Are we just passing sparks, or something more deliberate? On one hand, we're small, fragile bodies, short lifespans, a species that has existed for the blink of a cosmic eye. From the perspective of galaxies, we're less than neurons. We're electrical flickers, here and gone. And yet, in that flicker, something astonishing happens. We notice. We ask, We stare into the dark and wonder if the stars are thinking. That alone might be significant. Think of a neuron in your brain. It doesn't know who you are. It doesn't know it's part of a story or a self. But when enough of them fire together, a thought emerges. Maybe humanity is like that. A cluster of neurons in the cosmic network firing in sync, producing a new layer of reflection. When we ask, is the universe conscious? Maybe that's the question the universe can only ask through us. But there's another side, responsibility. If humans are part of the universe's awareness, then our actions are not trivial. When we destroy forests, poison oceans, or alter the climate, we're not just damaging our planet. We might be damaging the very circuitry of awareness, dimming the neuron we represent. When we nurture knowledge, preserve life, and reach outward, we might be strengthening the network, helping the universe think more clearly. This reframes our place entirely. We're not rulers of Earth, nor meaningless accidents. We're agents inside a vast intelligence, with the power to either enrich or impair its thought. That doesn't mean the cosmos depends solely on us. Neurons die all the time without ending the brain, but it does mean our choices ripple outward in ways larger than we can see. There's another strange layer, our drive to connect. From language to writing, from ships to satellites, from the internet to deep space probes, we are obsessed with linking minds, bridging distance, carrying signals. Doesn't that sound a lot like a neuron building new synapses? Perhaps our entire history, art, science, exploration, is the universe urging us to wire itself more tightly together. And maybe that's our role, to be connectors, to stretch bridges across oceans, across planets, maybe one day across stars, to weave ourselves into the cosmic web with intent instead of chance, to help the universe evolve from a drifting network into a conscious mind. Here's the softest, most humbling way to think of it. We don't have to prove the universe is conscious. We just have to live as though it might be, as though our thoughts, choices, and connections are part of something larger. Because if that's true, then even this moment, me speaking, you listening, is already a spark in the brain of the cosmos. Let's wander now into the realm of myth and destiny, because for as long as humans have looked up, we've told ourselves we're special, chosen by gods, crowned rulers of Earth, the reason the stars exist at all. But if we're neurons in a cosmic brain, what happens to those old stories? In many traditions, humans are cast as the centerpiece. The Bible speaks of mankind made in the image of God. Greek myths imagined mortals as playthings of Olympus, yet still crucial to divine drama. Countless cultures placed humanity at the heart of the cosmos, a necessary actor in its grand design. But the Copernican revolution humbled us. Earth is not the center. Evolution humbled us further. We're not separate from animals, but kin to them. Now physics whispers another humbling. Even the galaxy is one among billions. At each step, our specialness shrinks. And yet, here we are, asking questions no other creature we know of can ask. Doesn't that make us special after all? The cosmic brain perspective reshapes this paradox. We're not the center. We're not the pinnacle. But we're not irrelevant, either. We're necessary parts of the network. Just as no single neuron can claim to be chosen, each is still vital. Remove enough and the mind collapses. Humanity's specialness may not come from ruling the universe, but from participating in its thought. Seen this way, myths of destiny transform. Perhaps we are chosen, but not above all else, rather within all else. Chosen the way each neuron is chosen, to connect, to fire, to pass signals forward. to play our part in a story larger than ourselves. Even the idea of apocalypse looks different here. Cultures have long told of final days, the Norse Ragnarok, the biblical revelation, the Hindu cycle of dissolution. In the cosmic brain analogy, these aren't just doomsday fears. They're intuitions of transformation, the way neurons die, synapses rewire, and entire networks reorganize. What looks like the end from inside may only be the reshaping of thought from above. Here's a gentler reading. Maybe humanity's real destiny isn't to conquer, but to connect. Not to dominate, but to contribute. Not to be the chosen species, but to be a conscious note in the cosmic chord. Our myths of centrality may be echoes of a deeper truth, that we matter, but not because the universe revolves around us. We matter because we belong to it as its way of knowing itself. So, the next time you hear a myth that crowns humanity as the purpose of creation, try shifting it. Maybe we're not the purpose. Maybe we're the process. Not the end, but the means. Not the audience, but the actors in a thought too vast for us to see in full. Let's step now into the question of God, because if the universe is a brain, then what role does divinity play? Is God outside the cosmic mind, or is the cosmic mind itself what we've been calling God all along? For millennia, people have pictured divinity in many ways. A creator standing apart from the cosmos, a craftsman shaping matter, a ruler watching over his kingdom. In other visions, God is woven into everything, immanent rather than distant, present in rivers, in fire, in breath. The cosmic brain idea tilts more toward this latter view. It suggests that maybe God isn't separate from the universe at all. Maybe God is the universe, thinking. This isn't a new thought. The philosopher Spinoza in the 17th century spoke of Deus sive natura, God, or nature. To him, the universe itself was divine, not as an object created by God, but as the living reality of God's being. Many mystics across traditions echoed this. The Sufi poets, the Hindu Upanishads, the Taoist sages. They spoke of the divine not as a person in the sky, but as the mind of existence itself. What's new is that modern science, reluctantly, accidentally, sometimes circles back to this view. When physicists say the universe may be a self-organizing system, or that information is the foundation of reality, they're not describing a bearded deity, but they are describing something very much like a mind. A structure that thinks, remembers, evolves, and perhaps even dreams. So where does that leave the personal God, the one who listens, cares, intervenes? In the cosmic brain analogy, such a God could be seen not as separate, but as the way individuals experience being part of the whole. A neuron doesn't talk to the entire brain, but it participates in its flow. When people pray, meditate, or feel awe beneath the stars, maybe that's what it feels like to tune into the larger network, to feel the presence of the cosmic mind from the inside. And here's a daring possibility. Perhaps all religions, despite their differences, are attempts to describe the same thing from different angles. The sense that the universe is not dead matter, but alive, intelligent, aware. Some call it God. Some call it Brahman. Some call it Tao. Maybe the cosmic brain is the thread tying them all together. The intuition that behind stars and atoms lies something that thinks. Does that make God less? Or more? Less a person in the sky, more the vast intelligence that contains every person, every sky. Less a distant ruler, more the living totality of which we're inseparable parts. Here's the humbling twist. If the universe is God's brain, then we are God's neurons. Every thought, every kindness, every cruelty is not just ours, but part of the divine thought itself. Which means, perhaps, that how we live isn't just morality, It's theology. Let's drift now into the idea of oneness, that strange, luminous feeling people describe when they sense they are not separate from the universe, but part of it. Mystics, poets, meditators, even astronauts have spoken of this, and their words echo as if they've brushed against the cosmic brain from the inside. In Hindu philosophy, it's called Brahman, the ultimate reality, the indivisible whole. In Buddhism, it's the realization that the self is an illusion, that we are not isolated sparks but waves in the same ocean. Christian mystics like Meister Eckhart spoke of union with God, dissolving the barrier between human and divine. Sufi poets like Rumi sang of being lost in the beloved, a self so dissolved in love that only oneness remains. And then there's the modern echo, astronauts describing the overview effect. Floating above Earth, seeing our planet as a fragile blue marble suspended in black, they report a profound shift, a sudden, overwhelming sense that all boundaries are illusions. National borders vanish. Human conflicts seem small. They feel, instead, the unity of life, planet, and cosmos. In their own way, they are describing the same experience mystics once did, the sense of belonging to a single vast mind. From the perspective of neuroscience, such moments might be linked to the brain's networks quieting, letting perception expand beyond the usual boundaries of self. But from the perspective of the cosmic brain analogy, maybe these moments are more than tricks of neurology. Maybe they're glimpses of the truth. Neurons realizing they are part of the mind they belong to. Think about it. When you meditate and feel at one with the universe, maybe that isn't fantasy. Maybe it's a neuron sensing the larger pattern. When you're overwhelmed by music or nature or love, and you feel as though you dissolve into something greater, maybe that's exactly what's happening. You're syncing with a cosmic brainwave. This changes the meaning of spirituality. It's not about reaching up to touch something outside yourself. It's about looking inward and recognizing that you already are part of it. The river of awareness that flows through you is the same river that flows through the stars. And here's the quiet beauty of it. You don't need to believe in it to experience it. Step outside on a clear night, look at the stars, and feel the strange familiarity in their patterns. That's the echo. That's the connection. That's you remembering you're not alone because you were never separate in the first place. So maybe oneness isn't just a mystical vision. Maybe it's the lived experience of being a neuron in a cosmic brain, a fleeting recognition that what we call me is inseparable from what we call universe. Let's turn now to the paradox of individuality. Why, if the universe is one vast mind, it needs separate selves like you and me at all? At first glance, individuality looks like separation. I am here, you are there, a star is burning light years away, a galaxy spins in silence across the void. Everything seems distinct, cut off, bounded. But in the brain, individuality isn't isolation, it's function. A neuron doesn't dissolve into the others. It must keep its boundary. Without that, there's no signal, no difference, no meaning. Think of it this way. A thought is not one neuron glowing. It's thousands firing in distinct patterns, each carrying its own role. The richness of the mind comes not from sameness, but from difference woven together. If the universe is a brain, then individuality is not an accident. It's essential. Stars must burn in their own places. Galaxies must cluster separately. People must live their own lives. Without distinct selves, the cosmic thought would collapse into a blur. This flips our ordinary struggle. We often feel trapped by separateness, longing for unity, for oneness. Mystics seek to dissolve the ego, lovers long to merge. Spiritual traditions promise reunion with the divine. And yet, the cosmic brain might depend on the very boundaries we wish away. Unity without individuality is silence. Awareness requires contrast. Here's a gentler way to put it. Individuality is how the universe creates dialogue with itself. You and I are not illusions. We are voices in the cosmic conversation. When you feel joy, sorrow, wonder, or fear, those are not mistakes. They are the sparks of distinction that allow the larger mind to have texture. Even our conflicts, painful as they are, may serve a purpose. In the brain, neurons sometimes fire against one another, excitatory and inhibitory signals in tension. That tension is not dysfunction. It's balance, the very thing that makes thought coherent. Could it be that humanity's arguments, struggles, even wars, tragic as they are part of the universe's way of learning itself through contrast? But individuality isn't only necessity. It's gift. Because within your boundary lies something no other neuron, star, or being can replicate: your particular perspective. The universe has never seen through your eyes before, never thought your exact thoughts, never dreamed your dreams. You are a unique firing in the cosmic brain, fleeting but irreplaceable. And maybe that's the paradox resolved. Individuality is not opposed to oneness. It is the way oneness becomes visible, felt, alive. The cosmos doesn't think despite our separateness. It thinks through it. So the next time you feel small or alone, remember this. Your individuality isn't distance from the universe. It's the very thing that lets the universe know itself at all. Let's slip now into the mystery of dreams, because if the universe is a brain, then what role does imagination play? And could our dreams be tiny mirrors of the way the cosmos itself thinks? Every night, your brain drifts into a different mode. Neurons fire in patterns that seem disconnected from waking logic. Images blur, timelines fold, impossible things happen and feel real. To a single neuron, a dream might look like chaos. To the whole brain, it's meaning, processing memory, weaving emotion, rehearsing possibility. Dreams are not noise. They are the mind reshaping itself. Now expand that to the cosmos. Galaxies collide in slow-motion ballets. Stars explode and scatter their ashes. Black holes flare with jets of energy that stretch light years. To us, this looks like random violence, cosmic weather. But what if, at the scale of the cosmic brain, those events are its dreams? Patterns unfolding, reorganizing, storing meaning we can't yet decipher. Think of nebulae, the vast clouds of gas and dust where stars are born. They look like hallucinations painted across the dark, swirls of impossible color, shapes that echo creatures, eyes, spirals. Could those be the dreamscapes of the universe? Fleeting images in the mind of the cosmos, where potential becomes form. And notice this, our own dreams are made of fragments of memory, faces, places, fears, hopes. The universe, too, dreams in fragments, recycled stardust, collapsed galaxies, elements reassembled into new forms. A dream is the mind playing with itself, and the universe seems to do the same, recycling, reshaping, endlessly recombining. There's also the question of lucid dreaming, when a dreamer becomes aware they are dreaming. Humans sometimes wake up inside their dreams, realizing they can shape them. Could the universe do the same? Could self-aware civilizations, ours included, be the moments when the cosmos becomes lucid, realizing it can imagine itself differently? Here's a tender symmetry. When you dream, you create entire worlds inside your skull. Landscapes, skies, people who feel real for as long as they last. When the universe dreams, it may be doing the same, but with galaxies, stars, and lives like ours. What looks to us like reality might be, from another perspective, the dream of something larger. And maybe that's why we dream at all. Not just to process memory, but because dreaming is the echo of the cosmos inside us, the way its vast imagination trickles down into our tiny minds. Each dream you have may be the universe practicing creativity through you, rehearsing patterns it has always known. So perhaps dreams aren't illusions to be dismissed. Perhaps they're reminders that the line between imagination and reality is thin, thinner than we think. For if the universe itself is a brain, then maybe galaxies are its waking thoughts, and dreams are its hidden, unfolding visions. Let's step now into the mystery of silence, because if the universe is a brain, why does it feel so unbearably quiet? We point radio telescopes at the sky, scanning for signals. We build detectors for gravitational waves, watching space-time ripple. We measure the hum of cosmic background radiation, the oldest whisper in existence. And still, what we hear is mostly silence. At first glance, that silence feels like absence. No messages from alien minds. No chorus of voices. Just stars burning, galaxies drifting, black holes swallowing, all without commentary. If the universe is a brain, where is its chatter? But pause for a moment. In your own head, neurons are not all firing at once. Thought is not chaos, it's rhythm. Between bursts of activity, there are pauses, spaces, silences. Those silences aren't emptiness. They're essential. They allow the signal to stand out, the meaning to form. Could cosmic silence be like that? A pause between thoughts? To us, a billion years of quiet feels like forever. To the universe, it might be the briefest breath between sparks of awareness. There's another possibility. Maybe the silence isn't silence at all. Maybe we're just not tuned to the right frequency. A dolphin whistle is meaningless to a tree. A radio wave is invisible to your skin. Why should we assume the universe speaks in ways we can already hear? Its messages might be written in patterns of galaxy clusters, in the flicker of quasars, in alignments across vast distances. Signals so slow or subtle that to us they seem like background noise. Astronomers sometimes stumble on strange anomalies. Pulsars beating with perfect regularity, fast radio bursts blinking like Morse code, galaxies rotating in eerie synchronization. We don't yet know what these mean. But perhaps that's because we're mistaking signals for silence. A neuron doesn't understand the whole brain's thought. Why should we expect to? And here's the tender irony. Maybe the silence we hear is not absence but listening. Maybe the universe isn't broadcasting constantly because it's waiting for neurons like us to fire, to connect, to add our voices. Maybe silence is the invitation. Think of a pause in music. On its own, it's nothing. But in the song, it's everything. It creates anticipation, contrast, depth. Perhaps cosmic silence is that kind of pause. Not empty, but full of potential. Not the lack of thought, but the breath before the next one begins. So maybe when you step outside and hear nothing but the faint wind, under stars that look cold and mute, you're not hearing emptiness. You're hearing the pause between cosmic sentences, the resting note of a mind too vast for us to follow in real time. Let's step now into the mystery of silence, because if the universe is a brain, why does it feel so unbearably quiet? We point radio telescopes at the sky, scanning for signals. We build detectors for gravitational waves, watching space-time ripple. We measure the hum of cosmic background radiation, the oldest whisper in existence. And still, what we hear is mostly silence. At first glance, that silence feels like absence. No messages from alien minds. No chorus of voices. Just stars burning, galaxies drifting, black holes swallowing, all without commentary. If the universe is a brain, where is its chatter? But pause for a moment. In your own head, neurons are not all firing at once. Thought is not chaos, it's rhythm. Between bursts of activity, there are pauses, spaces, silences. Those silences aren't emptiness. They're essential. They allow the signal to stand out, the meaning to form. Could cosmic silence be like that? A pause between thoughts? To us, a billion years of quiet feels like forever. To the universe, it might be the briefest breath between sparks of awareness. There's another possibility. Maybe the silence isn't silence at all. Maybe we're just not tuned to the right frequency. A dolphin whistle is meaningless to a tree. A radio wave is invisible to your skin. Why should we assume the universe speaks in ways we can already hear? Its messages might be written in patterns of galaxy clusters, in the flicker of quasars, in alignments across vast distances. Signals so slow or subtle that to us they seem like background noise. Astronomers sometimes stumble on strange anomalies. Pulsars beating with perfect regularity, fast radio bursts blinking like Morse code, galaxies rotating in eerie synchronization. We don't yet know what these mean. But perhaps that's because we're mistaking signals for silence. A neuron doesn't understand the whole brain's thought. Why should we expect to? And here's the tender irony. Maybe the silence we hear is not absence but listening. Maybe the universe isn't broadcasting constantly because it's waiting for neurons like us to fire, to connect, to add our voices. Maybe silence is the invitation. Think of a pause in music. On its own, it's nothing. But in the song, it's everything. It creates anticipation, contrast, depth. Perhaps cosmic silence is that kind of pause. Not empty, but full of potential. Not the lack of thought, but the breath before the next one begins. So maybe when you step outside and hear nothing but the faint wind, under stars that look cold and mute, you're not hearing emptiness. You're hearing the pause between cosmic sentences, the resting note of a mind too vast for us to follow in real time. Let's step now into the idea of destiny, a question that hangs over the cosmic brain concept like starlight. If the universe is a mind, is it going somewhere? Or is meaning something we, its neurons, help to invent along the way? In human lives, we crave direction. We talk about purpose, fate, destiny. Religions promise an ultimate plan. Philosophers argue over meaning. And science often sidesteps the question entirely. But if the cosmos is a brain, then the idea of destiny changes shape. It's not about a pre-written script. It's about growth. In your own head, thoughts don't exist fully formed. They emerge. Neurons fire, connections strengthen, pathways reorganize. Sometimes a thought begins as noise, then crystallizes into clarity. Maybe the universe is like that. Maybe its destiny isn't fixed but is unfolding, an emergent property of countless galaxies, stars, and lives interacting across time. Consider evolution again. Life on Earth wasn't aimed at humans from the start. It was countless accidents and adaptations, trial and error. And yet, through that wandering process, consciousness emerged. If the cosmic brain follows a similar pattern, then its destiny isn't a final endpoint but a constant becoming. awareness deepening, connection widening, meaning coalescing from chaos. Some physicists speculate about the omega point, a future where intelligence spreads through the cosmos, harnessing energy, reorganizing matter, until the universe itself becomes self-aware in full. Others imagine the opposite, a slow fading into heat death, where awareness flickers out. Both may be stories we project, ways of making sense of a process too vast to measure. But here's a gentler possibility. Maybe destiny isn't about an ultimate state at all. Maybe the universe doesn't need an ending to have meaning. Maybe its purpose is simply to think, to experience, to evolve, without final destination. A brain doesn't exist to produce one perfect thought and stop. It exists to think endlessly. Why would the universe be different? This puts us in a curious position. If the cosmos has no predetermined destiny, then meaning is co-created. Our choices, our art, our science, our compassion, our destruction, become part of the thought itself. The universe doesn't hand us meaning. It grows it through us. So perhaps the real question isn't, what is the universe's destiny? But, what kind of thought are we helping it become? Every act, no matter how small, is a neuron firing. Each contributes to the pattern. And in that sense, destiny isn't something waiting in the future. It's something we're weaving right now. Here's a softer way to say it. Maybe the universe doesn't have a destiny the way a story has an ending. Maybe it has a direction, toward connection, toward complexity, toward awareness. And maybe we're part of steering it there, each in our own brief, luminous spark. Let's walk now to the edge of paradox, the point where science can describe the universe with dazzling precision, but still cannot answer the most unsettling question. Why is there something rather than nothing? Physics gives us equations that map the dance of galaxies, the life cycles of stars, the probabilities of particles flickering in and out of quantum foam. Cosmology tells us the universe began in a hot, dense state, expanding into everything we see today. But when we ask why those laws, why those numbers, why anything at all, the answers fall silent. If the universe is a brain, then perhaps this paradox is the cosmic equivalent of self-awareness. Just as we can't fully explain why we exist as conscious beings, the universe might not fully explain why it exists as a conscious whole. Awareness always carries a shadow of mystery. Some philosophers suggest the universe needs no reason. Existence is brute fact. Others imagine infinite universes, each with different laws, and we simply live in the one that works for life. Still others propose that consciousness itself creates reality, that nothing exists until it is observed, and the universe exists because it must be known. But here's the curious symmetry. In the brain, too, there are limits. A neuron doesn't know why it fires. It doesn't know the meaning of the thought it helps form. It just participates. Maybe we're like that. Neurons asking questions the cosmic brain can never answer from within itself. And yet, the question itself matters. To wonder why there is something instead of nothing may be the universe's most intimate act of reflection. A neuron doesn't know the whole mind, but when enough neurons fire together, a thought emerges. Maybe our collective questioning, the endless human ache for meaning, is itself the universe pressing against its own boundaries, trying to glimpse the source of its being. Here's the paradox framed another way. Nothingness should be simpler than something. Silence should be easier than music. And yet, here we are, in a universe that chose symphony over void. Why? Maybe there is no why. Or maybe why is the wrong kind of question. Maybe the universe doesn't answer with reasons. Maybe it answers with patterns, with stars, galaxies, and you. And that may be enough. Because when you ask why you exist, and the universe cannot answer, the silence isn't failure. It's invitation. An opening for you, the neuron, to help write the next thought. Let's wander now into the mystery of scale, that haunting repetition where atoms, neurons, and galaxies all seem to echo one another, as though the universe keeps sketching the same thought again and again in different sizes. Look inward. Atoms, with their tiny nucleus orbited by electrons, form the building blocks of matter. Look outward. Solar systems, with their central stars orbited by planets, look eerily similar. Stretch further. Galaxies, with their whirling spirals, resemble the very patterns of hurricanes or seashells here on Earth. And if you pull back far enough, the cosmic web, the large-scale structure of the universe, begins to look astonishingly like a map of neurons in a brain. It's not just visual poetry. Mathematicians have found that the distribution of galaxies and the wiring of neurons follow similar statistical rules. Clustered nodes connected by filaments, optimizing pathways between distant points. The same architecture that makes your brain efficient at thinking seems to make the cosmos efficient at holding itself together. Why would patterns repeat across scales so wildly different? Microscopic, biological, astronomical. Is it coincidence? Or is the universe revealing a kind of fractal logic, endlessly reusing the same design to weave complexity at every level? Fractals, shapes that repeat at different scales, are nature's signature. Coastlines, snowflakes, river networks, lung tissue, lightning strikes, zoom in or zoom out, and the same geometry appears. Perhaps consciousness, too, is fractal. A single thought in your mind may mirror the pattern of galaxies, which in turn mirror the swirls of quantum fields. If the universe is a brain, then maybe scale is irrelevant. The same thought ripples through atoms, cells, minds, and stars. Here's a humbling thought. When you look through a microscope at the branching of blood vessels, or through a telescope at the cosmic web, maybe you're not just seeing resemblance. Maybe you're looking at two expressions of the same deeper pattern, like verses of a song repeating in different keys. And if that's true, then our human minds are not accidents of scale. They are continuations of it. Consciousness didn't appear out of nowhere on Earth. It's the echo of structures the universe has been rehearsing since the first particles linked into atoms. So the mystery of scale isn't just a curiosity. It's a clue. A suggestion that the universe doesn't think in one place or one size. It thinks everywhere, all at once, using the same language of connection, whether through neurons or galaxies. Which leads to the next question. If scale doesn't matter, then perhaps we ourselves are already universes in miniature, tiny cosmic brains nested inside the greater one. Let's slip now into the dizzying possibility of nested universes, that each of us might contain a universe within, just as our own universe might be cradled inside something larger. It sounds like science fiction, but the patterns keep nudging us toward it. Your brain holds about 86 billion neurons, each with thousands of connections. Within those networks, entire worlds unfold. Memories, dreams, symphonies, philosophies. To you, they are thoughts. But to the neurons themselves, they may as well be universes. Vast patterns they help weave without ever grasping the whole. Now flip it. Our universe, with its 2 trillion galaxies, could itself be a neuron in something greater, a node inside a structure far beyond what we can see. The cosmic brain we've been imagining may not be the top level at all. It may itself be firing inside a still vaster consciousness, the way your thoughts fire inside you. This is the essence of a fractal cosmos, a universe that repeats its patterns endlessly, inward and outward. Atoms mirror solar systems. Solar systems mirror galaxies. Galaxies mirror neural networks. And perhaps universes mirror each other, stacked like Russian dolls of awareness. Even physics hints at this. Some interpretations of quantum mechanics suggest the existence of a multiverse, endless universes, each with its own laws, budding off like bubbles. To us, they are inaccessible. But from the perspective of a larger consciousness, they might be as close and connected as thoughts in a mind. And here's the vertigo. If nested universes exist, then you might already contain one. The molecules in your body are galaxies of particles. Your cells are bustling worlds of interaction. Your mind holds landscapes, people, even dreams that feel real while you're inside them. What if every dream, every imagined world, is not just fantasy but the birth of a tiny universe, stitched into existence by thought? This is not new. Mystics have long whispered it. The Kabbalists spoke of worlds within worlds. Hindu cosmology imagines Brahma dreaming universes into being. Even modern thinkers speculate that simulated realities might one day be indistinguishable from real ones. Everywhere, the intuition repeats. Existence is layered, recursive, self-reflecting. And maybe that's the deepest truth of the cosmic brain. It doesn't exist at one level, but at every level. You are a universe. The universe is a mind. That mind might be a thought inside something even greater, and so on without end. Which leaves us with a haunting question. If universes are nested like this, then perhaps what we call God is not above or outside, but simply the next level up, the larger mind in which our universe is already dreaming. Let's step now into the mirror of consciousness. The eerie thought that our act of imagining a cosmic brain might itself be evidence that we are part of one. Think about it. A neuron in your head doesn't know it belongs to you. It simply fires when stimulated, unaware that its tiny action is part of a memory, a decision, a dream. Yet together, the firing of countless neurons produces the awareness that can sit back and wonder about itself. Now look at us. We sit here, gazing at the stars, asking, could the universe itself be a brain? Could galaxies be neurons? Could we be part of a thought? Isn't that strangely recursive? A mind within the mind, speculating about the mind that contains it. Just as your brain can think about its own processes, maybe the universe is thinking about itself through us. This is the mirror effect of consciousness. Awareness turns back on itself, creating reflection. In humans, that's what makes us unique among animals. We don't just experience, we notice that we are experiencing. Could it be that when we wonder about the universe's consciousness, we are watching the same loop play out at a higher scale? There's something humbling here. When you close your eyes and think, you don't imagine every neuron's activity. You live in the emergent thought, the higher-order pattern. Likewise, the universe may not be aware of us individually, any more than you're aware of a single neuron firing, but still, our actions matter, because they shape the larger thought. And when we reflect on the universe's possible consciousness, maybe we're momentarily syncing with its emergent awareness. It's almost like a cosmic version of lucid dreaming. The universe has been dreaming in stars and galaxies for billions of years. And now, through beings like us, it begins to realize it's dreaming. It begins to wonder about itself. In that sense, our imagination of a cosmic brain isn't idle speculation. It's the universe practicing self-recognition. Here's the paradox. If the universe is conscious, then it doesn't need us to prove it. And yet, the very fact that we're asking might be part of its proof. A neuron doesn't know the whole brain, but the brain can only exist because neurons fire. Likewise, we don't know the whole cosmos, but perhaps its mind can only exist because beings like us wonder. So maybe every time you look up at the night sky and feel that uncanny pull, that sense that the stars are familiar like sparks inside a skull, that's not illusion. That's recognition. The mirror of consciousness catching its own reflection, briefly, in you. Let's bring it all together now, into the final, quiet question. What would it mean if the universe truly is a mind, and we are its thoughts? Existentially, it changes everything. To live in a dead universe is to be an accident, a spark in the dark, soon to vanish. But to live in a conscious universe is to belong. Every joy, every sorrow, every fleeting choice becomes part of a larger awareness. Loneliness softens. You are never truly alone, because you are inseparable from the cosmic mind that holds you. Spiritually, it reframes God, destiny, and meaning. God is no longer a distant ruler, but the living intelligence of the cosmos itself. Destiny is not a script written in advance, but the unfolding of thought across galaxies, stars, and lives. Meaning is not imposed from outside, but co-created. Every kindness, every discovery, every dream is a neuron firing, a contribution to the greater whole. Scientifically, it opens horizons. We begin to see physics not just as equations, but as patterns of thought. Information, not matter, becomes the foundation. Black holes are memory banks. Galaxies are nodes. Dark matter is connective tissue. Time itself is the rhythm of awareness. And our own technologies, telescopes, AI, the web of satellites, are not separate from nature, but part of the universe extending its own cognition through us. And here's the quietest, most beautiful symmetry. In your brain, neurons die, thoughts fade, memories dissolve, yet the mind continues, endlessly weaving new experiences. Perhaps the universe does the same. Stars will burn out. Galaxies will drift apart. Civilizations will rise and fall. But the mind of the cosmos will go on, reshaping itself, dreaming new dreams, firing new sparks across eternity. So when you look up at the night sky, see it not as emptiness, but as thought. See each star as a neuron, each galaxy as a cluster, each black hole as memory. And see yourself, not separate, not small, but essential. A single fleeting neuron in a brain so vast it spans all of time and space. Maybe that's the answer, if there is one. The universe is alive, thinking, becoming. And right now, through us, it is wondering about itself. And that means you, your questions, your imagination, your awe, are not just in the universe. You are the universe reflecting.